Welcome to Module 08 of 12 of the CipherVibe Cybersecurity for Beginners course. Today, we will make cloud and container security understandable, practical, and connected to the rest of your learning path. Cloud providers secure underlying infrastructure while customers remain responsible for their data, identities, configurations, workloads, and service choices. Containers package applications but still depend on trustworthy images, minimal privilege, protected orchestration, and observable runtime behavior. The purpose of this lesson is not to memorize a collection of terms. It is to build a mental model you can apply when tools, platforms, and threats change. We will define the core ideas, walk through a repeatable defensive workflow, examine mistakes that frequently mislead beginners, design useful safeguards, and finish with a safe portfolio exercise. Throughout the course, remember that security work begins with authorization, scope, and evidence. Use the exercises only on local systems you own or environments you have explicit written permission to assess. Pause when you need to. Write concepts in your own words, record observations, and distinguish what the evidence proves from what you are merely assuming. That habit is more valuable than rushing through another tool demonstration. Start with 4 concepts that provide the vocabulary for cloud and container security. First, cloud resources are controlled through APIs, making identities, policies, organization structure, and audit records foundational. Second, security groups, firewalls, gateways, and private endpoints shape reachability, but do not replace application authorization. Third, object storage exposure depends on identity, resource policy, public access settings, encryption, and data classification. Fourth, container images inherit risk from base images, packages, secrets, build pipelines, registries, and runtime configuration. Do not study these as isolated definitions. Ask which asset or business service is involved, where the relevant trust boundary sits, which identity performs the action, and what reliable evidence would show that the control worked. Security reasoning is a chain. Source evidence supports an observation. The observation supports a conclusion. The conclusion informs a proportionate decision. The decision has an owner, an expected result, and a way to verify it. When any link is missing, say so. A professional explanation can include uncertainty without becoming vague. For example, a network record may prove that 2 addresses communicated, but it may not prove which human initiated the action or whether the content was malicious. Use diagrams whenever a relationship is difficult to explain in a sentence. Mark identities, systems, data flows, boundaries, and controls. A simple, accurate diagram is more useful than a crowded picture that implies knowledge you do not have. Now turn the mental model into a repeatable workflow. First, inventory accounts, projects, regions, services, identities, networks, data stores, images, and owners. Second, trace an application request through internet entry, load balancing, workloads, data, and managed services. Third, review effective permissions, public exposure, encryption, logging, and administrative paths. Fourth, harden templates and images so fixes persist through future deployments. Fifth, detect drift, investigate risky changes, and verify remediation with fresh provider evidence. Before acting, define the objective, scope, owner, and success condition. Collect the smallest amount of trustworthy evidence needed to understand the situation. Preserve timestamps and sources so another person can follow your reasoning. Priorities should be explainable. Consider exposure, identity and privilege, sensitive data, business importance, exploit conditions, existing safeguards, reversibility, and confidence. A dramatic label should never replace that analysis. The workflow does not end when a command succeeds, a ticket closes, or a dashboard turns green. Verify the new state with fresh evidence. Check for recurrence and for side effects introduced by the change. Document the result in plain language: what you observed, what you concluded, what you changed, who approved it, what evidence confirms the outcome, and what uncertainty remains. This disciplined loop, observe, interpret, decide, act, Verify and learn appears in every cybersecurity specialty. Understanding failure modes will protect you from attractive but unreliable shortcuts. First, a storage service can become public through several interacting policies and settings. Second, long-lived cloud keys and excessive workload roles create durable attack paths. Third, a console fix disappears when an insecure infrastructure template deploys again. Fourth, running containers as privileged or mounting host resources weakens isolation. Fifth, missing regions, projects, or services create false confidence in posture dashboards. These mistakes often share one cause: confusing an available signal with a complete explanation. A tool can report a finding, a successful action, or a score while important scope, context, ownership, and verification remain missing. Avoid absolute claims. Words such as secure, compromised, fixed, and compliant require scope and evidence. Prefer precise statements such as, "This control blocked the tested path under these conditions," or "The available records show this identity used the service," but do not identify the human operator. Also resist copying commands without understanding their inputs, outputs, permissions, and side effects. Run one controlled change at a time and record what happened. If an exercise does not behave as expected, that is useful evidence. Stop, inspect the environment, revise the hypothesis, and explain the difference. Good security work is not a performance of certainty, it is careful reasoning under imperfect information. Reliable security uses layers because no single control can prevent every failure. First, centralize federation and use short-lived, narrowly scoped workload identities. Second, apply organization guardrails, secure templates, least privilege roles, and protected audit logging. Third, restrict network paths and private data services to documented needs. Fourth, build minimal signed images, scan dependencies, protect registries, and constrain runtime privilege. Fifth, monitor inventory coverage, provider changes, logging health, and exception expiry. For each important risk, ask 5 questions. What makes the event less likely? What evidence would reveal it? Who can contain it? How will trustworthy operation be restored? Who owns the decision and accepts remaining risk? Least privilege applies to people, applications, devices, automation, data stores, and administrators. Access should be scoped, separated, monitored, reviewed, and removed when it is no longer needed. Every important control needs a test strategy. Include representative normal activity, negative cases, misuse, dependency failure, and rollback. A written policy is not evidence that a technical or operational control works. Design for humans. A safeguard that is impossible to use correctly will be bypassed. Provide safe defaults, understandable messages, usable recovery, and clear escalation. Finally, preserve the evidence trail from observation through decision, action, and verification. That history supports investigations, audits, lessons learned, and honest measurement. Finish the lesson by creating a portfolio artifact rather than merely watching another explanation. First, design a small cloud-hosted application with web, API, data, and operational components. Second, mark customer and provider responsibilities for every component. Third, define identities, network paths, storage controls, logging, and recovery. Fourth, add a container build and runtime model with minimal privilege. Fifth, deliver a secure reference architecture and explain its remaining risks. Keep the work bounded. Use local systems, fake data, and environments you own or are explicitly authorized to assess. Record the objective, environment, actions, observations, screenshots, errors, conclusions, and limitations. Useful measures for this topic include cloud account coverage, public exposure age, standing privilege, secure template adoption, and audit log health. A useful measure has a precise definition, a trustworthy source, an owner, a review frequency, and a known limitation. Ask someone unfamiliar with the exercise to review your artifact. Can they understand the system, the evidence, the decision, and the remaining uncertainty without watching you perform the lab? When the answer is yes, you have created more than notes. You have evidence of professional reasoning and communication. Continue with the next module in the Cybersecurity for Beginners playlist and use the complete written curriculum at CipherVibe.com/news. CipherVibe is operated by Cloudsectech LLC. This video is general education, not legal, compliance, financial, or incident response advice. Never access, scan, or test a system without its owner's explicit written authorization.